Alright, so this is like the fourth video here. We're finally going to get into pyramids and cones. The idea is that with a pyramid and a cone, with a prism and a cylinder, the volume is area of the base times the height. Okay. Now the idea is that we're going to take the area of the base times the height. So that looks familiar, right? The top is, we're going to take that area of the base, we're going to multiply it times the height, but then we're going to divide by 3. You can think of it either way. We can say divide it by 3, or we can say multiply it by 1/3. It doesn't really matter. One of these two formulas is what you want to use. Okay. Same idea as what we had before, area of the base times the height, but now we divide by 3. Okay, that's the new information. In either case, even if that thing is not straight up, so here's a right cone, here's a non-right cone, okay, we're interested in the vertical height. Even if this thing goes all cockeyed and off to the side, this pyramid, we're interested in the vertical height, just like we finished the last video. So, let's find the volume of this pyramid if it has a vertical height of 14 centimeters. Well, it's a pretty straightforward problem. First things first, what's the base? The base is a square. 9 by 9, that means this base here, right here, would be 81 centimeters, right? So volume is equal to the area of the base times the height, all over 3. The area of the base is 9 times 9, which is 81. The height of this pyramid, they tell us in the words above, is 14 centimeters. If that was a prism, we'd be done, but because it's a pyramid, we got to divide by 3 because it comes to a point. So we take 81 times 14, which is 1134, divide it by 3, which is 378. It's 378 cubic centimeters. Pretty straightforward, right? Over here, what's the volume of this cone? Volume of the cone would be the area of the base. The base is a circle, so it's pi r squared. The radius is 16, so it's pi times 16 squared. We're going to multiply it by the height. Ooh, that's going to be a little bit tricky. We don't know the height. When we figure that out, we're going to divide it by 3. Okay, so the problem here is that we've got a right triangle. If this is 16 and the hypotenuse is 34, what is the height? What is this thing? Well, I can do Pythagorean theorem. 16 squared plus h squared is equal to 34 squared. 34 squared is 1156. 16 squared is 256. Take 1156 and subtract off 256. That means h squared is equal to 900. That means h, when you do the square root of both sides, is going to be 30. The height here is 30. That means I've got pi r squared for the area of the base. Multiply it by 30, which is the height. Divide it by 3, because it's a cone, you have the volume of the shape. 30 divided by 3, by the way, is 10. 16 squared, we just did that up here, that's 256. So you have 256 pi for the area of the base. 30 over 3 is 10. That's 2,560 pi's. It looks like we're in centimeters, so that'd be cubic centimeters for the volume of our cone. So divide by 3, that's the only change whenever we're doing pyramids and cones. Okay? That's it for this video. I've got one more that deals with composite shapes where we're doing stuff like this. Those are going to be some butt kickers, so you got one more video to watch. We're up to, I guess, 20 minutes total. So that's probably another 10 minutes we got. Three examples, okay? One more video to watch.